Okay, here's the circles. Number 24, they give you a circle O. They give you an inscribed angle at B that's 62 degrees, a central angle at O, and they're wanting to know arc AC. So I had to look up the formula for this. So when you have an inscribed angle that's on the circle, and it has a starting point, two starting points on the circle. So A, B, C. So A is on the circle, C is on the circle. So that inscribed angle is 62 degrees. The central angle at O, and it's called a central angle because it's at the center, it has the same endpoints, starting points at A and C. So because of that, these two angles are related. And here's how they're related. An inscribed angle, meaning angle B, is going to equal half of the angle, that's the central angle. So this is half of whatever O is, because it's smaller. You can see that it's smaller, even as bad as I draw it. So that angle is 62 degrees. That's half the measure of arc AC, and arc AC is what we're wanting. So to solve for AC, all we have to do is get AC by itself. So I'm going to multiply that 2 over, because it's the opposite of dividing by 2. So when I multiply 62 times 2, I get 124 degrees. So that's number 24. 25, in this picture I drew really bad, sorry. We have a circle. At point P, we have a tangent line. We have a secant line, that's PQ, or a chord. I can't remember, maybe it's a chord. And the center isn't even on here, so this is definitely not going to the center. And they give you another point O. And they want angle 1, and they tell you this arc, POQ, is 250. So this angle 1 has a relationship to the arc that's cutting it off, and it's because this is a tangent line and this chord, and they're connected on the circle. So this angle 1 is going to be half the measure of the arc. So again, angle 1 is half the measure of the arc, POQ. So angle 1 is half of 250, and half of 250 is 100, my finger won't hold it, is 125 degrees.